So the slope of a line is one of those things where when people get it, go, well, yeah, even anything to that, and yet when you don't get it, it can be hard to see, and it can be one of the areas where people just hit with maths and to go, oh, just geometry, that's just, I can't do maths, it's just beyond me. But yet, it's, we'll run through it. You need this for trigonometry, which is only a little bit relevant to statistics. We need it for calculus, which is absolutely at the heart of statistics, because calculus is the mathematics of predictable change, and we need that for statistics, which is the mathematics of uncertainty, or based on the mathematics of uncertainty.
Can you run that again? I always thought calculus was stuff you got in your teeth, which it is. But people throw the word calculus around as if it's like an ancient religion that only special people can know about.
Pretty much.
Yeah. But can you just say that sentence again with those two definitions? Because that was
so calculus is the mathematics of predictable change, which of course not much predictable change happens in the world, but we model it for all sorts of things.
Yeah, just gives you a rough idea.
It gives you a rough idea, and we need that rough idea and need to use the tools of that in order to get into something which is much more real world, which is the mathematics of uncertainty. Because the world is uncertainty, but finding out just how uncertain uncertainty is, and so on. So that's what we need it for. To understand it, you'll need to understand lines and angles and fractions, and particularly the way the fractions are ratio and a proportion, and numerators and denominators, how to multiply fractions, and the idea that a fraction is still a single number on a number line.
Okay. They're all... we're back at fractions, and I love fractions.
Fractions there, okay. So, the line going up an angle, there's a couple of different ways to measure that. One is to look at the size of the angle from the horizontal. So we might say that goes up at 45 degrees.
Yeah.
But a different way to measure it is to look at what's called the horizontal rise over the vertical run. So there it's risen up 3 units for each 4 units it's moved across. And what's important there is the ratio of the 3 units going up and the 4 units across. So if we were to make that vertical rise smaller, we have to change the slope of the line to fit that.
Is this where I reveal my nerdiness?
And talk about the fact that you love trains?
I love trains, so I'm probably the only person who does, but I was excited when we talked about this off air, the fact that because I've been into trains, and I apply this to gradients in railway construction. Great. So for all your people out there that are train nerds, we just bonded on that, and for most of the majority of the listeners who aren't, we can just ignore that, really. But I feel good about it.
Oh, this is excellent.
All right.
So when the vertical rise gets smaller, the angle gets smaller. Okay, back to where we were. Likewise, if that horizontal run gets smaller, then again the angle has to change. But when the horizontal run gets smaller, the angle gets bigger.
Yeah, okay. You see that?
Back to where we were. Now, if we don't have a horizontal run, the angle could be anything at all. So
we don't have a horizontal rise.
Sorry. If we don't have a vertical rise.
A vertical rise, yeah.
Sorry. The angle could be anything at all, so we need that. Could be that. If we don't have a horizontal run, again, the angle could be either. We need both of those things together to define them. But once we have them both, we define the slope of the line. So what are we looking at with those? Well, if we just look at those, we're looking at a ratio. In this case, 3 to 4, which we can express as a ratio, or in fact, we can express as a fraction. 3 and 4. And so you can see there, just as the numerator of a fraction gets bigger, then the fraction gets bigger. So if the numerator represents the vertical rise and the denominator of the fraction gets bigger, the fraction gets smaller. Hang on. That's right. If the denominator gets bigger, the fraction gets smaller, and vice versa. So we can express the horizontal rise as a fraction. Now, just like a fraction, if we multiply the numerator and denominator by the same thing, if we say that those units aren't units, they're 100 units, it's not going to change the slope at all, provided we multiply the numerator and denominator by the same thing. So it's a ratio that's important, not one particular thing.
So that's like in railways where it could be going up a rise of 500 metres across 10 kilometres.
That's
So
right.
yeah,
But it's not going to change the
it's not
slope.
going to change the slope.
Change the slope a little bit.
The ratio.
Yeah, we could halve that. The slope of the line doesn't change at all.
Yeah. Okay.
It's still going to be the same.
Mm.
And so if we want to start connecting those two ideas of the angle and the rise over run, that's when we get into trigonometry, we haven't looked for. But the fundamental thing from this video is just that there are those two completely different ways, both of which perfectly adequately describe the slope of a line.
Which is good for building railways.
It is good for building railways, and thank you for watching.